Okay, this video will quickly cover the additional two examples provided in the notes. So starting with the quadratic equation to be solved by graphing x squared minus 8x plus 16 equals 0. So again, we should be looking to graph the related quadratic x squared minus 8x plus 16. We look at a, b, and c. So a is 1 because there's no number in front. B is negative 8, and c is 16. We then locate the axis of symmetry, which again is the line negative b over 2a, x equals negative b over 2a. Again, if b is negative, then negative b would be positive, so that would be 8 over 2 times positive 1, giving us an axis of symmetry of x equals 4. The reason that is important, once again, is because that is where we center our table. To accurately graph a parabola, we need to have 5 points. So we create a table of values with 5 rows. Again, I like to show my work on these. It's not a bad idea and it doesn't hurt you, even to show what you're putting into the calculator. Axis of symmetry goes in the middle, which would be 4, meaning we are going to use the numbers 2 through 6 as our x values to graph this parabola. So when we plug in 2, we're taking this 2 and we're plugging it into f of x for x. So that would be 1 times 2 squared minus 8 times 2 plus 16. And you don't necessarily need the 1. So that would be 2 squared, which is 4, minus 16 plus 16. That would be 4. Remember that symmetry says that since we centered this graph on our axis of symmetry, that 6 would also turn out to be 4 when we plug it into the function. Same thing for 3. Again, we don't need the 1. So 3 squared minus 8 times 3 plus 16. That would be 9 plus, minus 24 plus 16, which would be 1. Remember that symmetry says that is also the pairing that we'd end up with if we plugged 5 in. Finally, plug in 4 to find the vertex of the parabola, because it is the axis of symmetry. That would be 4 squared minus 8 times 4 plus 16. That would be 16 minus 32 plus 16 for 0. Graph those points. 2, 4, 3, 1, 4, 0, 5, 1, 6, 4. Again, draw a smooth curve through those points. And then we are looking for the x-intercept. You'll notice that the vertex of this parabola is on the x-axis, meaning that we only have one solution, and that solution is x equals 4. Now in algebra, we refer to this as a double root. That is not going to be super important to us here in honors geometry, but it will going forward. Okay, we got one example to go, so let's do that. So here's our final example. Again, we're going to take the related quadratic function, f of x, which is just our trinomial as the body of the function. Again, we look up our a value, which would be 1, because there's no number in front of x squared, our b value, which is 10, and our c value, which is 24. We would then find our axis of symmetry. Remember, that is the line x equals negative b over 2a. That would be negative 10 over 2 times 1, or negative 5. So the axis of symmetry is the line x equals negative 5. That tells us where to center our table of values. That has to have 5 rows. Negative 5 goes in the middle row, which means we're going to be using the numbers negative 7, negative 6, negative 5, negative 4, and negative 3. We're taking those numbers and we're plugging them in. So negative 7 squared plus 10 times negative 7 plus 24. Okay, so we plug those in. That would be 49 minus 70 plus 24. Because negative 7 squared is positive 49. So 49 minus 70 plus 24 is 3. Symmetry right? Tells us that if negative 7 is paired with 3, so is negative 3. Plug in negative 6 squared plus 10 times negative 6 plus 24. That would be 36 minus 60 plus 24, which is 0. Remember that we have that symmetry paired there as well, meaning that negative 4 is also paired with 0. And finally, plug in negative 5. Negative 5 squared times 10 times negative 5 plus 24 would be 25 minus 50 plus 24, which would be negative 1. Graph those points. Negative 7, 3 is left 7 up 3. Negative 6, 0 is left 6 up 0. Negative 5, negative 1 is left 5 down 1. Negative 4, 0 is left 4 up 0. And negative 3, positive 3 is left 3 up 3. Remember that we are going to graph a nice smooth curve through those points. And then we are looking for the locations of the x-intercepts. That graph crosses the x-axis at two places. X equals negative 6 and x equals negative 4. So those would be our solutions, x equals negative 6 and x equals negative 4. That takes care of the additional examples. Thank you for your time.